A-level maths, we have this question which has a curve with equation y equals e to 3x, and we're told that the tangent to the curve at the point P is parallel to this line here. So, generally speaking, we know if we differentiate y, we are going to get the gradient of the curve. But we have nothing to substitute, so it's not really that helpful just yet. So the key is going back to GCSE and remembering what parallel means. So the gradient of this line will be equal to the gradient of that line. If we then equate them, we should get our answer. So the differential of this, nice and easy, it's just 3e to the 3x. And this, if we rearrange it, add 9y minus 23 and divide, so x over 9 minus 23 over 9. We only care about the gradient here, so then the gradient here is a ninth. So now we can make these two things equal. So 3e to the 3x equals a ninth. So let's solve for x. Divide both sides by 3. Leaves us with a 27th. Now you've got to take logs of both sides because you need to eliminate this e and bring down that 3x. So we'll take the natural log of both sides because we're working with e. And a step that I always get my students to add in is doing the power to the front here. Because it's important to understand what exactly is happening. Like the ln and the e don't just disappear. What actually happens is ln e is 1. Therefore, you're left with 3x times 1. And therefore, it looks like that. So here's a magic. Get used to understanding why this happens, and it should make your life a little bit easier. So we can divide by 3 now. We would be left with x equals a third ln a 27th. We need to simplify that a little bit more. So we've got the division here, so we can change that to a third ln 1 minus a third ln 27. ln 1 is 0, so cancel. And then we're left with minus a third ln 27, power to the front rule. So that's now going to be 1 over 27 cube rooted, which is a third. There are multiple ways to give this answer. I just double checked the question and they didn't want it in any specific form. So yeah.